All right, so this problem is a little bit different. You notice that you have an m squared, so that's fine. We're used to having something squared in these problems. But the problem is there's another m in there. And then that's going to keep us from getting that squared part by itself, at least at the beginning here. So what we want to try to do is we want to try to see if we can factor this into something squared, into a binomial square. And actually it's a perfect square trinomial. So if you think about 9m squared, that's 3m squared. And if you think about 4, that's 2 squared. This all equals 25. We're not going to worry about that just yet. And then if you look at the middle term, is it 2 times 3m times 2? And it is. So it follows that pattern. So if you remember, if you have a squared minus 2ab plus b squared, that's the pattern for a perfect square trinomial. That's going to factor into a minus b squared. So we have that. Here is our a, and here is our b, and it fits the pattern. And so we're going to factor it into a, which is 3m, minus b, which is 2. And so we get that perfect square trinomial factored into a binomial square. Now it looks like the last problem, okay? But let's continue with this one. Maybe there's some surprises coming. So we're going to take the square root of both sides. Now that we have a square part. All right, so in the parentheses then, that's what I'm going to have, 3m minus 2. And then I know the square root of 25, it's 5, right? Plus or minus 5. So this one's going to be a little bit different here because we don't have a radical part anymore. But we'll still take the 2 to the other side. So you have 3m equals 2 plus or minus 5. All right, and then let's go ahead and finish this off by dividing by 3. I say finish it off, but we're not quite done. So we get m equals 2 plus or minus 5 over 3. Well, I'm going to have these be separate. I'm going to have 2 minus 5 over 3. And I'm going to have 2 plus 5 over 3. But the thing is, I can combine those. So 2 minus 5, the first one's going to be negative 3 over 3, which is negative 1. So I'm doing a little bit of the math here. And then 2 plus 5 is 7 over 3. And that's not going to simplify, so I'll just have 7 over 3. But those would be the two solutions then. So there's no radical part. There's no I. It just works out that one's an integer and the other is a rational number, but they're both real numbers. Those are the solutions. So that was fun. And that's what you do if that happens. You know, if there's no radical, then you can do some more combining. Alrighty, very good.